Hi and welcome to arc length and area of a sector. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. Okay, so just to begin with, just a little bit of work with the definitions, just so we know what we're actually trying to find in this case. Now the name of the video is arc length and area of a sector. So the first thing is we need to know what an arc is. Now an arc is just any point on the circumference of a circle joining together two other points. So the section here would be an arc. But also, the way that I've drawn it here, this would also be classed as an arc because it joins together 2 points on the circumference. And also, this piece all the way around the outside would actually also be an arc because it's joined together 2 points on the circumference. The sector, now that is a very specific part of a circle. A sector is an area of a circle enclosed by two radius and an arc. And therefore, if I look here, I've got a radius and an arc. And therefore, this section here is a sector. But also, again, given the blue section, there is a radius and there is a radius. And therefore, the whole blue section would be a sector. And actually also, even the green section, which is actually a semicircle, that would be a type of sector. Okay, so in each of these cases, we're being asked to find the length of the arc. Now, the arc is a part of the circumference. So the first thing we need to be thinking about here is, if this were a full circle, what would be the formula for circumference? And that would be circumference equals pi times diameter. Now, given that information, we need to think about what we actually already know about these shapes. Now, this first one, the yellow shape, well, this is not a full circle. It has a 90-degree angle in the middle. Now, what that means is this is actually a quarter of a full circle. And therefore, this arc is actually going to be a quarter of the full circumference. But if we have a look at what we've actually been told, this 7 centimetres, what does that actually mean? Well, the 7 centimetres is actually the radius of this. If it were a full circle, 7 centimetres would be the radius. And so, what is the diameter? Well, the link between the radius and the diameter is that the diameter is 2 times the radius. And therefore, we'd actually be using pi times 14. But because this is only a quarter of the circle, we only want a quarter of this answer. And therefore, I'm just going to multiply by a quarter. And so all I do is grab my calculator and I'm going to type this in exactly as it is. So 1 quarter times pi times 14. And that equals 7 over 2 pi, which is correct, but let's change it to a decimal. It is 10.99557. If we went to one decimal place on this, well, that would actually just go straight to 11 centimetres. And so, in this case, we'd be looking at 11 centimetres for the length of that arc. In the red shape, we have, once again, only part of a circle. And the important piece here is the angle. What proportion of a full circle is 72 degrees? Well, 72 degrees, if we look at 72 out of the total circle, which will be 360, that is actually exactly the same as 1/5. And so, we need to do exactly the same thing as we did in the previous question. The circumference of the full circle would have been pi times diameter. We've been given a radius, and therefore we need to turn that into the diameter by doubling it, 12 centimetres. But in this case, because it's 72 degrees, which is only a fifth of the circle, we're going to do a fifth times pi times 12. And again, we're just going to grab our calculator and type that in exactly. So 1/5 times pi times 12. And that is 12 over 5 pi, which is 7.5398. If I'm going to one decimal place again, 7.5 centimetres. So 7.5 centimetres. And in the final one, we've been given 45 degrees on the inside of our sector. Now, 45 degrees, if 90 degrees is a quarter of the circle, well, that is half again, and therefore this is an eighth of a full circle. And so we're going to use 1/8, and we'll times that by pi, and we'll times it by the diameter. Now again, we've only got the radius here at 5, so we're going to have to double it to get the diameter. And then we're just going to type that into the calculator. 1/8 times pi times 10. And that is 5/4 pi, which would be, to one decimal place, 3.9 centimetres. Now, in this case, I have used a quarter for a 90-degree angle, I've used a fifth for a 72-degree angle, and I've used an eighth for 45 degrees. And that's because I'm able to work out what proportion of a circle that is. But if we didn't know the exact proportion, could we do this a little bit easier? Well, we can. There is a simple formula. The arc length is theta over 360, and theta just means whatever the angle is times pi times diameter. And so no matter what the angle is, even if it's something that doesn't go into 360 particularly nicely, it will still work to find the arc length. Okay, so next we're being asked to find the area of the sector. Now again, this is all to do with how much of a full circle we've got, and I've actually given you exactly the same shapes again. So in the first one, we have a right angle. If we have a right angle, that is a quarter of a full circle. If it's 72 degrees, well, 72 out of 360 we found before was a fifth of a full circle, and 45 degrees, that is an eighth of a full circle. And therefore, all we need to think about here is how do we get the area of the full circle, and then to find a quarter of it, or a fifth. So, the area of a full circle, that is pi r squared. But in this case, it's only a quarter of a circle, and so all I'm going to do is I'm just going to change this to be a quarter times pi times r squared. Now, r is the radius, and that is what we've actually been given this time. So times 7 squared. So we just grab our calculator and we type in 1/4 times pi times 7 squared, and we get 49/4 pi, but if we went to one decimal place, that would be 38.5. And so 38.5 centimetres squared. In the second one, we know that it's a fifth of the full circle, so we're still going to use pi r squared because it's still about area, and so all I'm going to do here is a fifth of pi times r squared, and r in this case is 6. And we'll type that into our calculator. 1/5 times pi times 6 squared, and that is 36/5 pi, or to one decimal place, 22.6 centimetres squared. And for our last shape, we know that this is an eighth of a full circle, and so we just need to times it by the area for a full circle, which would be times 5 squared, and see what we get. And so 1/8 times pi times 5 squared equals 25/8 pi. Let's turn that into a decimal. We get 9.8. And so 9.8 centimetres squared. Now again, could we have done this for situations where we weren't sure of what proportion of a circle it was? Well, we can. It's exactly the same method. We're going to use theta, being the angle, over 360, and then times it by the normal area of a circle, pi r squared. And so the first part is just telling us what proportion of the circle we are dealing with, and then multiplying it by the normal area. And so in our last set of examples, we've been asked to calculate the value of x in each shape. Now this means we could be looking for a length, which we are in the first question, or we could be looking for an angle like we are in the second one. And so we're going to have to use our formulas but work backwards in order to identify the value of x. So the first one has used arc length. So first of all I want to do is remind myself of what the formula for arc length is. And arc length is angle over 360 times pi times diameter. So in this case, what is the angle? Well, the angle has a little square, which means that that is 90 out of 360 times by pi times by the diameter. Now we don't know the diameter, we don't know the radius, and so that is still just d. On the left hand side, I actually want to know what the arc length is, and it's 6.28. And so how am I going to work out the value of the radius? Well, all I need to do is I need to leave d all on its own, and in order to do that I'm going to have to divide by everything here. So it's going to be 6.28 divided by 90 over 360 times pi. And so I'll type that into my calculator. 6.28 divided by, and then in a bracket, 90 over 360 times pi. I close my bracket. And if I do that, I get 7.9959. So if I were to go to one decimal place, well, that is 8 centimeters. But this, remember, is the diameter. So the diameter is 8 centimeters. What is the radius? Well, the radius would have to be half of that, and therefore the radius would be 4 centimeters. If we go to our second example, we've been given the area, and so we just need to think here, what is the rule for area? Well, area is the angle over 360 times pi times r squared. So what information do we know in this case? Well, we know that the area is 13.09, and we know that the angle is x out of 360, and it's been times by pi, and it's been times by the radius squared. In this case the radius is 5, so it's going to multiply by 5 squared. And so let's just box that off. If I want to find x, well, I'm going to need to do a little bit of division first. So I'm going to have to do 13.09 divided by pi times 5 squared in order to remove this section, and that would equal x over 360. And so if I want to get x all on its own, well, I would then multiply everything by 360. So we could do 360 times 13.09 divided by pi times 5 squared. And we can type that into our calculator. So 360 times 13.09 divided by shift pi times 5 squared. Close the bracket, get our answer. It comes to be 60.0001, and therefore to one decimal place x would equal 60 degrees. And so lastly, we are given the perimeter of this sector is 19.49 centimeters. Now it's very important that we just remember what perimeter actually means. It would mean the total distance around the outside, and therefore that is including the arc on the side, but also the two radius which enclose the shape. And so when we think of the perimeter here, we need to think about the arc, and the arc would be 25 over 360 times pi times the diameter. That would give us the arc, but then we would also need to add in the two radii. So add another x as one radius, and add another x as the other radius. Now, all I want to do here is I want to think about the diameter. Now, the diameter would be twice the radius. Now, we know that the radius is called x, and therefore I'm actually going to replace diameter here with 2x. And what we know is that this expression must equal 19.49. Now, I will say at this point, this is an extremely tough version of these questions, because what you need to identify here is that we can't just do a division, because we have addition going on as well. And so what we're actually going to do, we're going to need to, first of all, simplify what we have on the right-hand side. And so, if 25 over 360 is being multiplied by pi, I can call that 25 pi. But it's also being multiplied by 2x, and so I'm going to multiply all of this by 2, and therefore I would have 50 pi over 360, and that would be multiplied by x. The addition is then just adding 2x. Now, it may seem strange that I've done all of this, but there is a very good reason for it. If you can see that we have a common factor, which we do in this case, we have x as a common factor, we can then factorise the expression. And therefore x is our common factor, and so we can write x on the outside, and that is going to be 50 pi over 360 plus 2. Why is that useful? Well, it means that now if I want to find x all on its own, I can just divide by what is in the bracket. And so 19.49, I can divide it by everything that was in that bracket, 50 pi over 360 plus 2, and it will give me the value of x. And so we're just going to do that on our calculator. Set up a fraction. 19.49 is going to be divided by another fraction, 50 pi over 360 plus 2, and we get 7.999729715. If we went to one decimal place, we have that x is 8 centimetres. Like I say, a very tough version of these questions, but something you may come across in an exam. And so we come to the final question. It's the exam question. It came from the Edexcel mock papers, and it was on higher paper 2, so it is a calculator question. And we're told that the diagram shows a sector of a circle of radius 9 centimetres. The sector has a perimeter of 25 centimetres. Work out the value of x. So we are looking for the angle in this case, and we're going to give our answer correct to one decimal place. So again, we must recognise here what do we actually need for the perimeter. Well, we have the arc. Now the arc would be the angle over 360 times pi times the diameter. Now the diameter, if this is the radius at 9, then the diameter would be 18. But because we are finding the perimeter in this case, we need to include this 9 centimetres. It would need adding on, but we'd also have to add on this 9 centimetres. And so we now know that this is equal to 25 centimetres because that is the perimeter. And so 25 equals this equation. So how are we going to work out our answers? Well, we've got 25 equals theta over 360 times pi times 18 plus 18. So the first thing I can actually do here, just to make it a little bit easier, is take away the 18. If I take away 18, that is 7 equals theta over 360 times pi times 18. And if I'm trying to find theta, which is x, I'm just going to divide by 18 and divide by pi. So 7 divided by pi times 18. That would give me theta over 360. And if I want to do this in one big jump, Well, I can now just multiply everything by 360. So 360 times 7 over pi times 18. And that will give me theta. And so we'll just type that straight into our calculator. 360 times 7 over pi times 18. And it is 44.56. Now it asks for one decimal place, so 44.6. Theta is 44.6 degrees. Done.